For years, the AI race has been about one thing: making models bigger, more data, more parameters, more compute. But NVIDIA just released an AI that's doing the opposite. And that's why it matters. It doesn't try to be the smartest model in the room. It tries to control the room. NVIDIA has unveiled an 8 billion parameter model designed not to replace large AI systems, but to coordinate them. It's built to manage multiple specialized models, tools, and workflows across complex multi-turn tasks, what the industry now calls Agentic AI. And if this approach works, it may quietly redefine how modern AI systems are built, deployed, and scaled. For the past few years, AI development has followed a predictable pattern: bigger models, more parameters, broader capabilities. That strategy delivered impressive results, but it also created structural problems. Large general-purpose models are expensive to run, difficult to control, and increasingly inefficient at specialized tasks. They hallucinate. They struggle with long-horizon decision-making, and they often blur responsibilities between planning, execution, and validation. In real-world systems, robotics, enterprise automation, scientific pipelines, this one model does everything approach breaks down. Complex tasks don't just require intelligence. They require planning, delegation, tool use, verification, and feedback loops. Not creativity alone, coordination. This is the gap NVIDIA is directly targeting. NVIDIA's new 8 billion parameter model is not designed to outperform state-of-the-art language models in raw intelligence. Instead, it serves as an orchestrator. Its primary function is to interpret goals, break them into steps, assign those steps to specialized models or tools, track progress across multiple turns, and adapt when something fails. Think of it less like a brain and more like a system controller, a management layer sitting above other AIs. Crucially, this model is optimized for decision routing, state tracking, and tool coordination, not encyclopedic knowledge or creative output. 8 billion parameters may sound small in today's AI landscape, and that's intentional. An orchestrator doesn't need to know everything. It needs to know what to call, when to call it, and why. Smaller models are cheaper, faster, and more predictable. They can run continuously, manage multiple agents at once, and remain responsive in real-time systems. By keeping the orchestrator lightweight, NVIDIA enables scalable agent systems without the cost explosion of giant foundation models running every step. This reflects a shift away from intelligence maximization towards system efficiency optimization. Agentic AI systems are fundamentally different from chat-based models. Instead of responding to a single prompt, an agent plans several steps ahead, calls tools or other models, evaluates results, and iterates until a goal is met. This process requires memory, state consistency, and control logic, tasks that large language models struggle with when used alone. NVIDIA's orchestrator acts as a meta-agent, coordinating a network of specialists rather than trying to replace them. This is how modern software already works. Microservices instead of monoliths. Schedulers instead of mega-processors. AI is now following the same architectural logic. Most major AI labs today are optimized around foundation models. Their products, pricing, and business models are built on the assumption that a single, highly capable model sits at the center, accessed through APIs, scaled through usage, and improved through size. In that world, value accumulates around raw intelligence. Bigger models, better benchmarks, more parameters. But an orchestration-first architecture changes that equation. When intelligence is distributed across many specialized models, the most important capability is no longer how powerful any single model is. It's how well the system as a whole is designed, integrated, and coordinated. If AI systems become modular, interchangeable, and centrally managed by orchestration layers, the competitive moat around best-in-class single models narrows significantly. In that world, the most valuable asset isn't the smartest model. It's control over the runtime, the workflows, the tooling, and the compute. And that shift is uncomfortable for labs whose advantage depends on model supremacy. In an orchestrated AI world, intelligence becomes a component, not the product. Models can be swapped, Specialists can change, capabilities can be distributed. What matters most is who controls execution, which models are called, how resources are allocated, how failures are handled, and how performance is optimized in real time. This moves strategic power away from standalone AI labs and toward platform owners who control infrastructure at scale. This is where NVIDIA enters the picture. NVIDIA doesn't just build AI models, it builds the environment those models live in. GPUs, inference engines, high-speed networking, simulation platforms, optimization libraries. NVIDIA sits beneath the entire AI stack. An orchestration-centric architecture aligns naturally with this position. Models that efficiently schedule workloads, delegate tasks across hardware, and dynamically optimize compute usage in real time. This isn't just an AI research experiment, it's a strategic platform move, one that reinforces NVIDIA's role as the backbone of modern AI systems. This architecture matters most outside consumer chat. In robotics, a single intelligent agent must coordinate vision systems, motion planning, sensor fusion, and safety controls, often in real time. In enterprise workflows, AI systems must interact with databases, APIs, documents, and human approval loops across long, branching processes. In science and simulation, I must manage complex pipelines with validation and verification at every stage. These are not intelligence problems. They are coordination problems, and this is precisely where orchestration-focused AI systems excel. The future of AI likely isn't one model ruling everything. It's many specialized systems, managed by fast, focused controllers. Foundation models remain important, but they shift roles. They become components, not kings. AI evolves from a single mind into an organized system, and that transition fundamentally changes who wins. NVIDIA's 8 billion parameter orchestrator isn't flashy. It's not built to dominate leaderboards or impress in demos, but it addresses a problem many AI systems are quietly running into: coordination. And sometimes the most important AI in the system isn't the one that talks the most. It's the one deciding who gets to talk at all.